It is Britain's first all-electric 2,000 horsepower hypercar.
Avaya being successful is incredibly important.
For over 70 years, Lotus has carved out a unique sporting niche. However, to secure its relevance in a greener market, the marque must push the boundaries of engineering.
If this company is going to survive, they have to go straight for the end goal.
To survive the times, the marque must innovate their way to the top by engineering a new electric motor and transmission system, crafting a one-of-a-kind battery, and finally, developing a shape that ingests the air instead of fighting it, in order to create their very first all-electric ultimate supercar. It consumes the air from 0 to 100 kph in less than 3 seconds. Hits the 300 mark in under 9 seconds. And has a top speed of over 320 kilometers per hour. The 2,000 horsepower Lotus Avaya.
I think what Lotus is doing with the Avaya is establishing itself in the marketplace as an inventor of the EV hypercar, one of the first movers.
The Avaya is unlike nearly any other car on the market. One might expect a vehicle like this to come from a traditional supercar power, like Ferrari or McLaren. Yet it doesn't. Instead, every single Avaya is the product of one of the tiniest sports car manufacturers in the world.
Lotus is a very small volume British sports car producer that specializes in lightness and simplicity.
The Avaya represents a major shift and a necessary risk for the marque. For over 70 years, the company has focused on crafting lightweight sports cars. Instead of flashy, ultra-extreme rides.
Lotus is the underdog of the underdogs because Lotus never went for the supercar excess. Lotus went the other way and said, we don't need excess, we need simplicity.
In the automotive industry, there are 3 main tiers of sporting vehicles. Sports cars, which are typically fun and reasonably accessible. Supercars, which sit a level above in performance, looks, and cost. And finally, hypercars. Extremely rare, flashy, and sophisticated rides that live at the cutting edge of high performance. Lotus has a lot of experience creating entry-level sports cars, but no experience engineering its own hypercar.
Lotus has always been about engineering simplicity, and that ultimately results in handling. What Lotuses do better than any other sports car has always been ride and handling.
While the marque is celebrated for putting the sport in sports cars, it never actually builds very many vehicles. Since its inception, the company has produced an average of less than 2,000 cars per year. In comparison, mainstream players like Toyota or Volkswagen routinely sell millions of cars in a single year.
Lotus is one of these sort of insider brands, right? To the mass market, maybe they don't exist, but to deep inner sanctum car nerds, they're the holy grail.
However, the low-volume car producer experiences rocky financial times. Over the years, the marque takes a wild ride that results in 5 different owners during the past 4 decades.
They've probably been bankrupt more than they've not been bankrupt, but have kept going by sheer will.
While Lotus has operated as a niche manufacturer, The dawn of the EV, or electric vehicle era, changes everything. Now, Lotus must rethink its strategy or possibly disappear forever.
Of all of the makers of sports cars, Lotus is in the most precarious situation because all of the things that are integral into the Lotus philosophy are going away without question.
We had to relaunch Lotus to really put it out there, and we had to go up against the competitors. I mean, genuinely fight against the competitors.
When the car industry begins going green, most electric vehicles are intended as people movers. At the same time, many traditional supercar companies hedge their bets by using hybrid technology.
What's really bold about what Lotus is doing is they're leapfrogging all of the hybrid stuff, all of the mild electrification, and going full hog electric.
There was no point in Lotus going that hybrid in the middle, so it was stay with combustion or go straight to EV and help develop technology and be right with the innovators.
Supercars were always about real speed and big drama and just excess. Lotus skipped right over that space and went to the hypercar, and more importantly, the electric hypercar. And I think that's because Lotus realized the supercar in traditional terms with a loud screaming engine has to go away. So what comes next? Speed. And if you're gonna do speed, nothing beats electricity.
Electricity helps you go fast and keep the lights on. Something that's extremely challenging for the marque when Matt Windle is hired in 2017.
If you ask somebody about Lotus then, they didn't even know that we still existed as a car company. It was a company that was on its knees, if I'm totally honest. I walked around and I was like, there's a car company here, a proper car company. The facilities we've got manufacturing facilities, we've got design facilities, we've got testing facilities. Everything was here. It just needed belief.
Conviction that comes from nearly 10,000 kilometers away. The same year that Matt Windle is hired, Chinese automotive conglomerate Geely becomes the marque's latest benefactor when it acquires Lotus for £100 million.
Ultimately, they needed a patron, and that was Geely.
The infusion of capital comes with a new plan of action. By 2028, the marque wants to sell 100,000 cars a year. That's a bold proposition, since it takes the marque 7 decades to build its first 100,000 vehicles. The Avaya project is a way to capture the public's attention and entice buyers to consider the marque's other products.
It is a challenge, but it's an opportunity as well. There was the negative that we didn't have a brand that was established, but allowed us the freedom to do the products we wanted to do and take the brand the way we wanted to go as well.
Now, instead of limping along building a small number of cars, the marque can expand its ambitions as it attempts to catch up with the major supercar companies, thanks to its innovations.
We see Lotus as an innovator, and it's fallen behind in the last 25 years. So it was, okay, what can we do? What can we do that's special, that's going to challenge our people? And we ended up with a hypercar.
Really, the first thing was to decide what a future hypercar looks like. We decided we wanted to go fully electric. It needed to be a sort of statement of intent for Lotus.
Unlike a traditional internal combustion car that has one engine, Lotus engineers determine that in order to hit its 2,000 horsepower target, the Avaya will need 4 independent electric motors, plus 4 separate electric transmissions, and a massive, one-of-a-kind pyramid battery, none of which exists when the project begins.
It's easy to dream stuff up on paper. You've got lots of ideas, we've got lots of opportunity, but very quickly we found out that technology didn't exist. Everything had to be invented, everything had to be developed.
If the marque wants to survive and prosper in the future, it has to rethink how a hypercar works and how it looks. Introducing the Avaya is a terrific challenge that aims to help Lotus rival famed car manufacturers like Porsche and Ferrari.
We just said we're going EV. A lot of people didn't agree with it. There's people that still don't agree with Lotus going EV.
While some purists might object to the move towards an electric vehicle, the marque has to adapt to stay relevant in a greener automotive industry.
If you look at Lotus's history, Lotus's models tend to last a very long time by necessity. Lotus doesn't have the time or the engineering resources to go out and dip their toe into hybridization when we all know we're going electric, period.
To avoid peril, the brand turns to head designer Russell Carr. He's a 30-plus year industry veteran and the guardian of the marque's visual identity.
Russell is great, isn't he? Russell's a Lotus institution. Cut Russell in half and he would bleed yellow and green.
I think supercar design comes from just a lifelong passion of cars, constantly looking around you, understanding the history of where sports cars came from, just taking inspiration from other things around, whether or not it's fast jets, sharks, anything really that is about speed.
Russell's quest for speed begins at an early age.
I grew up with a passion for cars. I can remember as a very small child being transfixed by seeing a Jaguar E-Type. I then started drawing cars from a very early age. So then I thought, well, I want to be a car designer.
In 1990, Carr joins Lotus and starts steadily climbing the ladder until he lands the top design job in 2018.
We design sports cars as a day job. It's pretty cool, can't complain. But to design a hypercar is something very special. You know, it could be a once-in-a-lifetime experience.
By definition, hypercars are rare. It's entirely possible that this is Carr's only shot at designing one.
We'd never done a hypercar before. There are some brands who've got some great hypercars out there, so it had to be different. Very simple brief. Fairly quickly, it became clear that it was going to be electric, and it wasn't just going to be electric, it was going to be a lot of horsepower.
Once engineers settle on a 2,000 horsepower, 4-motor, all-electric technical powertrain, the next task is for the design team to craft the vehicle's exterior shape.
Everything we do has to be beautiful and glamorous, which sounds obvious, but it's really easy to go off into some sort of science fiction, dramatic design that may be fashionable for 5 seconds. We're always thinking, what makes a Lotus?
For the past 7 decades, Lotus has built cars that feature one internal combustion engine. However, in the electric era, that's no longer true. The Evia's powertrain consists of 4 separate electric motors that sit near the corners of the vehicle. This allows Carr and his team to investigate an entirely new design language.
Right from day one, we wanted to do what the aerodynamicists call porosity, allow the airflow to go through the car as well as over the car.
Combustion-powered supercars try to force their way through the air with brute force. The Evia doesn't. Its exterior is crafted to encourage air to flow through it instead. It's a radically different approach to supercar aerodynamics.
It's a fighter plane in an age of kites. It's a completely different level of technology. Most car design relies on pushing the car through the air, creating a hole in the air and the airflow flowing round the outside. We wanted to allow the car to pass through the air in a fundamentally different way. We wanted the airflow to flow through the car, not just round the car.
To find inspiration, the team turns to nature and echoes how rocks are hollowed out by wind over centuries.
The car breathes the air rather than pushing it out of the way.
Traditional supercars use horsepower to overcome air resistance. The Evia aims to ingest the air at the front of the car instead.
The whole front end is significantly more porous compared to any other vehicle. It's like comparing a butterfly net to a parachute. It allows the airflow to flow through it rather than catching it.
The air ingested at the front adds downforce, which is the airflow that pushes a vehicle into the ground. And it helps cool the brakes and the battery pack. Yet where the air goes next is the real key.
We take the airflow from the front and we ingest it under the nose, pass it over the front winglets that we've got under the nose there to generate some downforce like Formula One wings. And then that airflow is passed inboard of the front tyres and then out through the side of the car here. The rest of it flows over and into these Venturi tunnels down the side of the car.
The tunnels are named after Italian physicist Giovanni Venturi. In 1797, he discovers that pressure, counterintuitively, reduces when it flows through a constricted area, while velocity actually increases.
We've created these Venturi tunnel, where you take a volume of airflow in through a channel at the front, you squeeze it through a smaller aperture, and then you expand it behind the car.
The Venturi tunnels help the Avaya hit its high-performance targets by reducing drag or the air resistance the vehicle faces at speed. This is crucial because the power needed to overcome drag increases in proportion to the cube of velocity. If a car needs 200 horsepower to overcome the air resistance at 240 kph, then it'll need 1,600 horsepower, or 8 times as much power to double the speed.
This whole aerodynamic philosophy was the backbone behind what we were doing.
The state-of-the-art aerodynamics influenced the Avaya's exterior, which leads to a very unusual design language.
And the next step is we start sketching, because that's the way we communicate.
Designers worked in traditional mediums before taking their work into the digital realm.
Let's not discount the way it looks. If you want to talk about something that you see on the street that would make everyone turn around and fall over, you make a shape like that.
When you're attempting to reimagine your brand for a new, all-electric era, a cutting-edge exterior design is only one part of the equation. Now, Lotus engineers must figure out how to power it too. For years, the hypercar space is dominated by marques with distinctive combustion engines. However, in an EV or electric vehicle world, how an engine sounds isn't nearly as important as your battery.
The problem with electric cars is the battery. The battery is so heavy that the biggest engineering challenge is where you put that.
Most modern electric vehicles use a skateboard layout where the car's batteries are placed in the floor. This puts the weight down low, but increases the height of the car. However, the Avaya does something entirely different. Engineers create a new type of pyramid layout that centralizes the battery and its weight in the middle of the car.
We didn't want to put it in the floor. We actually wanted to put it in the center of the car, behind the driver, to mimic a mid-engine sports car, to make the car really agile and fun to drive.
Mid-engine cars typically handle better because they increase stability and improve traction, which in turn helps the vehicle handle better. This is due to the vehicle's low polar moment of inertia.
The result is something called having a low polar moment of inertia, which is a terrible phrase that means all of the car's weight is concentrated in the center. And what that does is make the car want to pivot and turn very quickly.
The new battery layout challenges current automotive industry thinking, something that Lotus has been doing for nearly 3/4 of a century.
The Lotus way is not restricted by convention. It's a question of analyzing the problem or the opportunity, which often can be the same thing, and quickly identifying the most efficient way of realising the best solution.
Clive Chapman is the keeper of the flame and a living link to the past.
Earliest Lotus memory would have been in Lotus road cars with my father at high speed, more often than not, and the beginning of quite an exciting childhood.
Over half a century ago, in post-war England, Clive's father founds Lotus and then proceeds to reshape Formula One.
1948, and the first Lotus, first Grand Prix, 1958. And then just 5 years after that, totally dominated the World Championship. That kind of stratospheric rise carried on.
Between 1963 and 1978, Lotus vehicles win 7 Formula One titles. Making the marque one of the most successful race teams of the era.
More often than not, in the early 70s, Lotus was winning the Grand Prix, and he'd leap over the pit wall, throw his hat in the air, within inches of the car. Just the most exciting thing you can imagine.
While the victories earn glory, it's the company's technical innovations that make it legendary. Lotus is the first F1 race team to use an engine as a structural element of the chassis. They introduced sponsorship to the sport and are one of the first teams to rethink aerodynamics on their cars.
When Lotus actually started to become successful, it was David versus Goliath, and David was winning. And David didn't have a lot of respect for the establishment either.
Today, Lotus continues the hunt for maximum performance in the virtual world.
This is the driving simulator. So this is where we test our vehicles in the virtual environment, getting the opportunity to test our assumptions long before we cut any metal or cast any carbon fiber.
Welcome to the company's Advanced Driving Simulator. A state-of-the-art testing tool and the perfect way to find the best location for the car's new battery.
We can test our assumptions and also be brave in experimentation as well.
Engineers spend hundreds of hours developing the Avaya in the simulator.
This machine is huge in its capability and performance, so it moves laterally, longitudinally. The cabin will pitch, roll, heave. So motion cueing is really trying to make a computer game feel like real life.
A computer game with very real implications. Using their findings, engineers decide to centralize the battery in the middle of the chassis. This mimics a traditional mid-engine sports car and allows the team to lower the floor, seating position, and roof, while shrinking the ride height to just 105 millimeters. That's roughly twice the height of a golf tee.
Lotus is clearly looking at front to rear weight distribution. Putting it in a central pillar, basically, moves all the masses, the driver and the battery, into the center of the car.
So this is an Avaya battery, 718 kilos, that's the heart, the power plant of the car, 2.17 megawatts, 93 kilowatt hours, completely ground up bespoke architecture that we've had to develop to get the performance and the weight in the right position for the Avaya.
At peak power, a single battery can run a fairly modern and efficient English home for about 2.5 weeks.
The battery's built a bit like a pyramid. We're trying to keep the mass down. The Lego bricks come in like a pyramid.
Bricks that are hand-assembled at Hyperbat in Coventry, England.
This facility supports our Avaya program. What we try to do here is perfect our battery technology.
The process begins by testing individual battery cells. Then the cells are built into modules. before being assembled into a battery pack.
Once we do that, we put the casing on, and then we put the power electronics on top of that, and then put a top cover on.
Finished batteries are then shipped to the Lotus factory in Hethel, England.
The biggest challenge was it was going to be our first fully electric vehicle. And then how do we make an electric vehicle handle like a Lotus? That was our big question.
Anytime you design, engineer, and develop a new vehicle, in an attempt to reimagine your brand, there are questions. However, when you bring an entirely new type of vehicle to market, some of the answers you seek don't actually exist yet. So, you have to invent them. To blaze a new trail, Lotus engineers throw out the conventional high-performance measuring sticks in an attempt to redefine the hypercar, and by extension, the mark itself.
We haven't designed the car to go fast from standing starts. We've designed the car to go fast from 0 to 300k in one hit.
The Avaya looks fast at launch, yet it actually goes even faster once it gets going.
When you first launch, the tyres can't cope. That bit between nearly 100 miles per hour and 200 miles per hour is faster.
During hard acceleration, the Avaya generates additional downforce as the speed increases. As the force pushes the car into the ground, the amount of tyre touching the road increases. The larger surface area means there's more traction available, and that allows even more power to be sent to the wheels.
North of 100 miles per hour, and we're really generating the downforce, pushing the car into the road. We can just put more and more and more torque in, and that's when the car really comes alive.
The Avaya blasts from 0 to 300 kph in under 9 seconds. That's 5 seconds faster than the Bugatti Chiron, one of the fastest combustion-powered cars ever made.
The Avaya beating a Bugatti by multiple seconds to 300 kilometers an hour sounds outrageous, and it is. And the electric car is an order of magnitude faster because it's instant, and nothing will keep up with that Avaya.
The Avaya features 500 horsepower at each wheel. And just one electric motor is more powerful than any previous entire Lotus car.
To me, the most interesting thing about Avaya is 4 independent motors. That just means a sea change in handling.
Throughout its history, Lotus focuses on handling. The Avaya project is no different, only it's done in an innovative way, thanks to something called torque vectoring.
Torque vectoring is a really fancy term for a wheelchair. I can turn the wheelchair without a steering wheel. All I have to do is turn one wheel forward and one wheel back, and I can turn in any direction. If the Avaya has individual control of each wheel, that means it can turn the car without the driver turning the steering wheel. That is a quantum leap.
A quantum leap that takes place at the Helix factory in Milton Keynes, England, where a team of dedicated workers hand-assemble each electric motor. The units use magnets to create motion and are comprised of 2 distinct parts, a stator and a rotor.
With an electric motor, you have the teeth. So we take 18 of these and we turn these into a stator.
The stator is a temporary magnet, while the rotor is a permanent one.
These are the equivalent of electromagnet. So if you pass current through these teeth, you can turn this into electromagnet, which you can then attract or repel the north and south poles within the rotor, and that's how you make the motion of the rotor go round.
Conceptually, electric motors work thanks to the same basic magnetic principles you might learn at school. However, the magnets in the Avaya's motors are much more powerful.
And your typical fridge magnet is about 50 gauss. These would measure at 14,000 gauss. So that's 280 times stronger than your average fridge magnet.
A Gauss is a unit of measurement for magnetic fields. And it takes a strong magnet to power a fast car. Something they test back in Hethel on the company's engine test benches.
We're currently in what was the old engine test area, and some of the other test plots we've seen Formula One engines.
On the test bench, the new electric motor revs to 17,000 RPM, or revolutions per minute.
Electric motors are instantaneous, meaning in the course of a single second, 1,000 or multiple thousands of times, that car can apply power or a drag to each one of the wheels to get it to turn where it needs to go.
The Avaya's electric motors can adjust their power delivery on the fly. However, to get all that energy to the ground requires engineers to rethink the basics of the automobile yet again and leverage some Silicon Valley know-how. Throughout the years, Lotus never sells very many cars. What keeps the mark in business is the company's in-house engineering firm, a company within a company.
There is an unspoken secret in the automotive industry that if you need help, you just call Lotus. And Lotus has had its fingers in everything, from entry-level hatchbacks to serious sports cars.
Lotus Engineering is a part of our business that people probably don't understand. It's about 40 years old now. So we've worked for a number of companies. A lot of it's confidential, and we're still doing that today.
We've worked on many EVs over time. You know, some a lot of people know about. I'm not sure how many we're allowed to talk about. There's some well-known brands that started here.
Lotus Engineering's EV, or electric vehicle knowledge, goes back to the beginning of the green movement, thanks to an unlikely Silicon Valley source.
For the Tesla Roadster, Lotus actually re-engineered the Elise chassis to Elon Musk's specifications to make sure that it could deal with the electric motor.
In the early 2000s, Tesla is not a household name. It barely resembles the game changer it'll become. In fact, it needs help.
The business was 2 years old. It was really forming. It was a very exciting period. It's a hugely different company now.
Struggling to bring its first vehicle to market, Tesla turns to Lotus Engineering.
The Roadster 1 was built here, and a lot of the engineering work was done for Tesla as well.
Now, Lotus is using some of that knowledge and attempting to elevate the game by introducing one of the most powerful EV hypercars ever made. To do it, they'll need to find a way to get their 4 electric motors' collective 2,000 horsepower to the ground.
For the most part, electric motors don't require transmissions in the way that we typically have them.
The electric transmission's job is to reduce the speed of rotation so that the tires can keep up with the electric motors.
The Avaya has 4 transmissions, but what that really means is that connected to each motor is a gear set that slows down the rotation of that motor to a wheel speed.
To realize their vision, Lotus engineers ask the experts at X-Track to help craft the new electric transmission. Since 1984, the company has manufactured transmissions for the highest levels of motorsports. The Avaya's electric transmission is a single-speed epicyclic unit that transmits the electric motor's motion to the ground.
We have a single-speed epicyclic gearbox that is about 95 millimeters wide, about 12 kilos in total.
The build begins by cutting raw metal. Before carving the gears. Then a mechanic hand assembles each set. Finally, the electric transmissions are tested on a multi-axis testbed.
One gear means that we've got that continual acceleration all the way through that range. We don't have a gear shift that would lose that momentum and reduce your overall acceleration.
The single-speed electric transmission isn't just small, it's also effective. When combined with the Avaya's battery and electric motors, the entire powertrain can operate at 98% efficiency.
Avaya is unique as it goes to 0 to 100 kilometers per hour in under 3 seconds. 200 kilometers per hour from 0 in under 6, but then to 300 kilometers per hour from standstill in under 9 seconds.
Astonishing performance that now must come to life inside the final assembly hall, where it takes a long time to build a fast car. It's a 2,000 horsepower all-electric hypercar, and a vehicle that aims to help a historic British motoring marque enter a new era. The Lotus Evija.
One thing that we're really proud of is how much of this car, I mean, big key elements are British. You know, it's 100% engineered in Britain, but about 90% by part count is sourced in Britain. About probably 75% by cost is sourced in Britain. So it's a huge, huge British engineering tour de force, this car.
Once, the United Kingdom was the #2 car maker in the world, but no longer. Today, it ranks 14th in the global car industry.
The British car industry has had a pretty tough run. It's been a long time since we've had steady, continuous success coming from there. Evija is the chance to put England back on the map.
Bringing an Evija to life begins inside the Lotus factory in Hethel, England.
We're at Hethel in Norfolk, which is about an hour and a half away from London. We're on the east side of the country, a little bit out of the way, really.
Unlike other English automakers that are clustered in the Midlands, Lotus stands apart in the eastern side of the country.
Developing an EV vehicle has a lot more challenges for us because we haven't done this. We've jumped from what we knew with internal combustion engines to fully EV 800-volt battery vehicles. So that's a big jump.
Few have seen the technology. Even fewer will see the Evija in real life. The team aims to build just 2 cars per week. And only 130 examples will ever be made. Each costs a staggering £2 million.
Everything in here is hand-built. There's no electronic aid in any of the production. It's a very specialist car.
The facility features 10 workstations that move just once per day.
It's a hypercar. It's a £2 million hypercar. I'm not sure I'll get to say I've worked on a £2 million hypercar again.
Massively rewarding. You know, it's massive personal achievement to be involved in this project. It's one of the bucket list things where you're not going to get a second chance to deliver a hypercar.
When new Evijas hit the streets, they'll represent the first all-electric Lotus, and perhaps a window into where the entire supercar genre is headed.
Historically, Lotus has not focused on supercars. They've focused on sports cars, which is a strange distinction. Is speed the most important thing, or is the experience the most important thing? Keep it simple, and it's a sports car. Go crazy in excess, it's a supercar.
The Evija is a mission-critical project that forges its own path in the quickly evolving all-electric automotive space.
The Avaya is a philosophical shift in the way we deal with handling. It's basically the hand of God. You are controlling the car by electrons.
The Avaya produces 2,000 horsepower, yet weighs just 1,687 kilos, giving the car a better than 1-to-1 power-to-weight ratio.
And just as you exit the corner into a half a mile straight, the numbers just go around like a fruit machine in front of you, and you're pulling genuinely 20, 30, 40 miles per hour more than you've ever experienced in any other car. And that's when you just realize that its potential.
There is no wrapping your head around it. Having this much power means that this thing can accelerate more quickly than someone falling out of a plane. This is when we go from fast to insane.
As a brave new electric vehicle future unfolds, the Avaya represents a sea change in high performance. It's different to almost any other previous hypercar ever made, and perhaps the best chance for Lotus to innovate its way to sustained success. The only question is whether customers are ready for it.
The purpose of the Avaya was to not just show what we could do as engineers, but it was the sort of statement of intent from all directions that Lotus is back.
For over 70 years, Lotus has been a racing legend and a niche manufacturer. The Avaya is a bold, technologically driven step to help the Mark enter a greener supercar era.